In today's video, I will read this ECU. It's a Siemens. It's a SID301. It's from a Renault 2 or Megane 2. I don't remember. I had it as leftovers. I cloned the ECU from my customer because the original ECU, as you may see in video, it was water damaged. I did not clean up. I just read it and copy to another ECU. He didn't want to repair or something because it's a really cheap ECU in my country. For that reason, I will try to read it with Multi-Prog from Xhorse. In the past, I did the job with another tool. I did it with I think it was Xprog, if I remember correctly. But let's proceed with reading. For this ECU, according to the schematic, I will need to use the MCU adapter. Normally I need to solder here on BDM port and connect this adapter to the computer. Sorry, also what I extra need, I need to provide some power and ground to the pins. I have these cables. I took them from a CAS or a K-Tag clone, I don't remember, but I'm using them for the connection. So let's begin. Also, I will include the pinout. I will include the pinout. It's included in Multi-Prog documentation, but I will show you also the pinout in the video when I switch to the computer. Until then, I will need to identify some cables which I need to solder. Okay. It's a little bit hard because I have it in the schematic as a reset, PFO, DCO, but here are stated different, only the colors, the green, the blue, and blah blah blah. And like always, it's only by the colors I need to connect. I hope I will connect properly. So let me switch to the right length and do the soldering job. So the first one on this side on the top, it's the green. In the schematic it's called VFO. What I will do, I will try to zoom a little bit in. Yes. And I will add some flux to my working area and then proceed with soldering. Okay, my soldering iron need to wake up. It will take some seconds. Okay, it's up, and then proceed. We have checked the length. It will go properly. I hope I will not mix up the connection schematic. Here I need 1, 2, 3 connection pads. And I will need a blue It's written blue on it. I hope it will match the colors with the pinout. Then I will need a brown or orange. Yeah, it's orange, not brown. Okay. Don't want to burn this nice silicone. Okay, it's orange or brown, because I have also brown. Okay, maybe this to it will not work. Let me check again. Seems to be orange. And this should be the gray line. Okay, I hope it will be okay. And I will need the gray, brown, get away. The gray wire. Okay, bad soldering, good soldering. What I will need also, on the small connector and the big one, I will need to provide ground and plus. So normally I will use one ground, which say it's here. Trying to fit in. For some reason doesn't want to go in. But I will zoom out. And I will need a power, which is a small pin. The third one from here. And another one, the first, 1, 2, 3, 4. 1, 2, 3, 4. And here. I think it's not the best choice, but I will use the orange. 1, 2, 3, 4. Strange. So the powers are the small pads. Small pins. Okay. This I don't need anymore. Okay, now I have the powers connected. What I said, orange and red are common. They will solder with DC power I need. VDD, no. I need DC power. I will just solder like this. Okay, it will be harder to solder like this, but I will try to do it. Let's see if it will work. Okay. I don't need, but I need. I lied. My bad. Okay, I definitely need some flux here. I will add a little bit of flux. Get some more solder. Okay, not a perfect solder, but I need only for this job. But I will need also clear my way and connect the ground here. This one, I hope it will go without flux. Okay, I'm using only one wire, so I solder wire to wire. Okay, it's making the connection. That's perfect. So I need to make sure I don't short something. I remove out of my way these cables. And let's connect to the device. Okay. Everything connected to the device. I will leave everything like this and switch to the computer. Okay, we are at the computer. It's a general info. It's the algorithm how we can read it BDM. The manufacturer is Renault and the part name it's a SID301. So to the connection diagram we have which cable we should use, the MCU adapter, and in the second picture we have the pinout for the ECU. Here it's also stated which color, orange, go to here where I was thinking it was a brown, but it's an orange. And everything looks good. Now I will select this ECU and we have two options how we can read it. External flash and external EEPROM. What I see here, we have some extra settings. Erase before programming, verify after reading, verify after programming. In some cases, uh, I think with Xprog I had an error of verifying after reading. But let's read first the external EEPROM memory. Okay, the chip ID detection succeed. As you can see, we identified. Also, we have the buffer of the external EEPROM. It was readed 100%. Now we are in the verify state and we have data. Overall, it took 12 seconds to read the EEPROM memory. As you can see, the VIN number is here and we have some data. Also the external flash. Let's hit on the read button and see how it will work. So chip ID, MPC, detected, buffer of what type of external flash, and the reading process is here. Always check on the log what it's doing. Also, as you can see, we have the VCC, not using amps, but we have DC power and we are using 0.160 amps. That means the ECU it's power up and it's not readed, it's using the power. Okay, reading the flash it's taking some time from what I see. It's not the end of the world, but it's working. That's the main good thing. You can read it and you can do your job easily. In the future, I will try to include newer ECUs. This type of ECUs, I have it in my storage from previous jobs and I keep them for spare parts. Normally, the newer ECU, I don't keep them on the stock or in my warehouse. I'm buying, I'm doing the job, and that's it. And in some cases, the customer takes the old ECU also back. That his option or choice. But if the channel will grow, I will put more newer stuff. But also this type of ECU, it was quite tricky to be readed with, let's say, the clone tools. Normally on this ECU, I'm using the Xprog in the past. Now I tend to move my work and get the best out of the multi-prog and try to do all the jobs if the programmer is capable. If it will be proven by the time it's really working, I will phase out a lot of my tools from my workshop. Slow reading, but really this is not an issue for me. If it's take 30 seconds or 5 minutes, because at the end for me the most important is to have the job proper done. I know for some of you the speed really count, but for me I rather take 5 minutes than 30 seconds with failures. Let's see, 92%. I know after the reading it will be a verifying process. This can give an error. I hope not. But then I can uncheck the verification and have a complete reading. So I was right, close to 5 minutes. So normally the reading of the flash took 4 minutes and 14 seconds. The verification, it will take the almost same amount of time, because what it's doing in this verification process, it's reading one more time and checking address by address if it's matching with the previous read of the memory. If you don't know what is the verification process in general of a programmer, are two reads with comparison between each address. And if something has changed, it will give a verification error. If not, everything will be good, green, and that's it. Also on the reading process, the verification, it's similar. First, it's writing the content to the memory. Then it's reading the content and compared with initial file you have set to be written on the memory. It's checking again each address one by one if it's matching. Of course, if it doesn't make checksum correction during the writing. If it's making the checksum correction, that will be included also in the verification process. Because in the checksum correction, some address will have the value changed. Okay, 60%. But if you want to do this job faster, you can unmark this option and you will have only the reading process time. That's up to you how you want to handle this process. Normally, I keep the verification there. Even if it's only the reading, it's good to be there. If I don't write this ECU, and I will just take the file from this ECU and write to another, if I'm on the speed, then I will unmark the verification process. But I need to have the car in my workshop in order to can test the new ECU if everything is working. If I do a remote job, then I will take all the measures to have everything verified twice, double, 3 times, and then send the issue to my customer. Okay, so the chip data verification succeed. The same time, almost couple milliseconds difference. Total operation time was 8 minutes and 32 seconds. As you can see, we have data from the flash, we have data from the EEPROM, we can save, and definitely we can write. In this case, in BDM, you always need to erase before programming. But that's it. Okay, as you saw, the ECU was read successfully through BDM with Xhorse Multi-Prog. What I will do, I will unsolder my wires, and yeah, that's it. This ECU I will not really assemble. I will just throw the cover back and put it back to my storage, where I can use some of the components if I need to repair another ECU or get some component which I don't find. But this I don't really count on the spare parts because also was water damage. I don't know how it's looking on the other side. I did not even try to look further. I think this ECU price in euro here on Romanian market, it's close to 20-25 euro a used one. So for 25 euro a used one, yeah, don't even try to repair. And that's it for today video, or for now. So BDM are clean, everything looks shiny. We'll give some alcohol, and that's it. I will find the cover, a nice cover, and go back as bed. If you like my video, Please subscribe, like, share it, and see you next time.